Good morning, students. Welcome back to 9th Science, Unit 13, Chemical Bonding, Part 3. Now let us recall what we learnt in the previous classes. Introduction of chemical bond, Cauchy-Lewis approach to chemical bonds, octet rule, unstable electronic configuration, Lewis dot structure, types of chemical bond. The second bond, that is a covalent bond. It is also called as an atomic bond. According to Lewis concept, when two atoms form a covalent bond between atom H and H, in between they form a covalent bond. Each of the atoms attain the stable or octet electronic configuration of the nearest noble gas. Since the covalent bond is formed because of the sharing of electrons which become common to both the atoms. So, in between the atoms a covalent bond is formed because of the mutual sharing of electrons. So, it is also called as atomic bond. The bond is formed between the atoms. So, it is also called as atomic bond. Formation of covalent bond. Now come to the picture. Let us consider the two atoms A and B. Atom A has one valence electron and the atom B has one valence electrons. So, they need one more electrons to complete the stable electronic configuration. So, both the atoms they approach each other. So, each atom they contributes one electron and resulting in the shared electron pair. Here both the atoms they share only one electron. So, here a shared electron pair, one pair of electron. So, here one covalent bond is formed between the two atoms A and B. Here thus both the atoms acquire a filled valence shell electronic configuration which leads to stability. So, only one electron pair contains two electrons. So, only one pair means here only one covalent bond is formed between the atom A and B. This is the formation of covalent bond. Then covalent, the types of covalent bond. There are three types of covalent bond. First one, single covalent bond represented by a line between the two atoms. For example, hydrogen H2. In between the two atoms H and H, a covalent bond is formed. So, a single line, only one covalent bond is formed between the two atoms hydrogen. So, this is a single covalent bond. Then double covalent bond is represented by a double line between the two atoms. Oxygen molecule O2. Here oxygen two atoms, but here the two bond is formed here. So, it is a double covalent bond. This is an oxygen molecule example. Then triple covalent bond is represented by a triple line between the two atoms. Example, nitrogen N2. In between the two atoms, three bonds. So, it is called as a triple covalent bond is in between nitrogen or N2. Here this is a triple covalent bond formation. Then the explanation with the formation of hydrogen molecule. Hydrogen molecule, come to here hydrogen molecule. Here how many molecule means here how many hydrogen, here two hydrogen. So, in hydrogen molecule two hydrogen atom here. So, the formation of covalent bond in between the two atoms of hydrogen molecule is come to the picture. Hydrogen atom, atomic number 1. So, the valence electron, only one electrons in the valence shell. Here another hydrogen atom, only one electrons in the valence shell. So, both the atoms they need one more electrons to complete the stable filled electronic configuration. So, here both the atom, they sharing each electrons. So here 2 electrons, or it is called as a pair of electrons. Pair means it contains 2 electrons. So it is only one pair of electrons. So here only one bond formation between the 2 hydrogen atom. So this is called as a hydrogen molecule H2. Hydrogen molecule is formed by 2 hydrogen atoms. While forming this molecule, both the hydrogen atom contribute 1 electron, sharing 1 electron to the shared pair, and here both the atoms, they acquire a stable, completely filled electronic configuration. For example, the resemblance of helium. Helium has the atomic number 2. So the hydrogen bomb formation in between the hydrogen atom, here only one, a single bond is formed between the 2 hydrogen atoms. This is a high formation of hydrogen molecule. Now come to the illustration 2, the formation of chlorine molecule. Chlorine, Cl2, molecule Cl2, chlorine molecule. Here how many Cl here? 2 Cl chlorine atoms. 2 chlorine atoms, they form a chlorine molecule Cl2. Now come to the picture. This is a chlorine atom. For example, this is chlorine atom. This is also a chlorine atom. Chlorine, the atomic number of chlorine is 17. So how to write the electronic configuration? 2, 8, 7. So the valence electrons, only 7 electrons in the valence shell. So they need one more electrons to complete the stable octet electronic configuration. So both the chlorine atoms, now come to the picture, outermost shell 1, 2, 3, 4, 5, 6, 7. And this chlorine atom also, the valence shell, it contains only 7 electrons in the valence shell. So both the chlorine atoms, they need one more electron to complete the stable octet electronic configuration. So both the chlorine atoms, they sharing only one electron. Both the atoms, they sharing only one electrons. Now count the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. And here you count this chlorine. 1, 2, 3, 4, 5, 6, 7, 8. So here this is a both the atoms, they have the 8 electrons in the outermost shell. So they achieve the stable, completely filled electronic configuration. So here one pair of electrons. So in between the chlorine atoms, only one covalent bond formation between the chlorine atoms. So a chlorine molecule. So it is called as the chlorine molecule. The formula of chlorine molecule Cl2. Now come to the example or illustration. Third one, formation of methane molecule. The molecular formula of methane is CH4. Only one C, 4 hydrogen. Only one C, 4 hydrogen atoms. So carbon, come to the picture. Only one C, and the carbon atom, the atomic number of carbon is 6. 2, 4. So the carbon, 4 electrons in the outmost shell. 1, 2, 3, 4. So the carbon atom, they needs 4 electrons to complete the stable octet electronic configuration. So these 4 valence electrons is sharing with 4 hydrogen atoms. Each hydrogen atoms contains only 1 electrons in the valence shell. So this 4 hydrogen atoms, they sharing with the 4 carbon atoms. So here there is a sharing of electrons. Now here this is a methane molecule. Center, this is carbon. Here this is hydrogen, 4 hydrogen here. And this carbon, this hydrogen, they sharing here. This hydrogen, they sharing here. And this hydrogen, they sharing here. And this hydrogen, both the atoms, they sharing here. So both the here, how many shared formation here? One pair of electrons. So here one bond formation here, and here another pair of electrons. So another bond formation here. Then another pair of electron, another bond formation here, and another pair of electron here, another covalent bond formation. So totally 4 covalent bond is formed in between the carbon and the hydrogen. So the molecular formula of methane is CH4. Methane molecule is formed by the combination of 1 carbon and 4 hydrogen atoms. The carbon atom has 4 valence electrons. So these 4 electrons are sharing with 4 hydrogen atoms to achieve the stable octet electronic configuration by the shared pair of electrons. Here 4 pair of electrons here. So the bond formation here, how many covalent bond for single group? 4 single covalent bond formation between the carbon and the hydrogen molecule. This is the formation of methane molecule, that is CH4. Now come to the next example or illustration, the formation of oxygen molecule. Oxygen molecule means O2. In O2, 2 oxygen atoms. So come to the picture. Oxygen has it has atomic number 8. So how to write the electronic configuration? 2, 6. So the outermost shell contains 6 electrons, 1, 2, 3, 4, 5, 6. And this oxygen atom also, it contains 6 electrons in the valence shell, 1, 2, 3, 4, 5, 6. So both the oxygen atom, they needs 2 more electrons to complete the stable octet electronic configuration. So both the atoms, they sharing 2 electrons. Now count the oxygen here, 1, 2, 3, 4, 5, 6, then 7, 8. Totally 8 electrons in the valence shell. Now come to the next oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So both the oxygen atoms, they achieve the stable octet electronic configuration. Here 2 shared pair of electrons means here there is a 2 covalent bond formation between the oxygen molecule. So oxygen molecule is formed by 2 oxygen atoms. Each oxygen atom has 6 valence electrons. These 2 atoms achieve the stable electronic or octet configuration by sharing a 2 pairs of electrons. So a double bond is formed in between the oxygen atoms, that is O2. The next illustration or example, that is the formation of nitrogen molecule, N2, N. Here come to the picture, formation of nitrogen molecule, 2 nitrogen. So this is first nitrogen, the nitrogen has the atomic number 7. The electronic configuration is 2, 5. So each nitrogen atom, they needs 3 more electrons to complete the stable octet electronic configuration. Now count the valence shell, 1, 2, 3, 4, 5, and come to the next nitrogen atom, 1, 2, 3, 4, 5. So both the nitrogen atom, they need 3 more electrons to complete this stable octet electronic configuration. So each nitrogen atom, they sharing 3 electrons. Now count the valence shell, 1, 2, 3, 4, 5, 6, 7, 8. Now come to the next nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. And both the atoms, nitrogen atoms, they have the 8 electrons in the outermost shell. So they achieve the electronic configuration. So here how many pair of electrons? 3 shared pair of electrons. So in between the nitrogen atoms, triple bond formation, 3 covalent bond is formed in between the nitrogen molecule. So this is a triple bond is formed between the 2 nitrogen atom. So this is a nitrogen molecule, that is N2. Nitrogen molecule is formed by 2 nitrogen atoms. Each nitrogen atom has 5 valence electrons. So these 2 atoms achieve the stable, completely filled electronic configuration by sharing 3 pairs of electrons. So hence a triple bond is formed in between the 2 nitrogen atom. This is the formation of nitrogen molecule. Then, what are the characteristics of covalent compounds? First one, physical state. Depending upon the force of attraction between the covalent molecule, for example, hydrogen, H2, O2, N2, the bond may be a weaker or stronger. Sometimes it is weaker and some molecules are stronger. So, the covalent compounds exist in gaseous state or liquid state or solid form. For example, oxygen, O2 is a gas, water, H2O is a liquid, and diamond, C, carbon is a solid. So, sometimes it is weaker and sometimes it is stronger. Here, electrical conductivity, covalent compounds do not contain charged particles. So, so they do not form plus or minus ions. So, it is a bad conductor of electricity. Melting point, except diamond, diamond means C, and also silicon carbide, they have all the other covalent compounds have low melting and boiling point compared to the ionic compounds. Then solubility, covalent compounds. What are covalent compounds? Tell some examples of covalent compounds. Nitrogen, oxygen, methane are readily soluble in non-polar solvents. Non-polar solvents means like benzene, C6H6, or toluene or carbon tetrachloride, CCl4, and they are insoluble. They do not dissolve in polar solvent like water, H2O. So, this is only soluble in polar solvents like benzene or carbon tetrachloride. Hardness and brittleness. Covalent compounds are neither hard nor brittle, but the covalent compounds are soft and also waxy like structure. Then reactions. Covalent compounds undergo molecular reactions. Hydrogen is a molecule, oxygen is a molecule, nitrogen is a molecule in solutions, and these reactions are very slow, but ionic compounds are very fast. These are the characteristics of covalent compounds. Now come to the last topic, Friedmans Rule. In the year 1923, Friedmans found an experiment through his X-ray crystallographic studies that some of the ionic compounds show covalent compound. Ionic compound, so examples of ionic compound is NaCl, MgCl2, AlCl3. These are ionic compounds. Sometimes this shows the covalent character based upon the Friedmans rule. Friedmans rules are formulated by considering the charge of the cation. Cation means plus. Based upon this, you have to find the relative size of the cation and the anion, plus and minus ion. The first rule, when the size of the cation is small, plus, okay, positive ion is small and that of the anion is large, negative, minus is large, means the bond is of more covalent character. And greater the charge of the cation, plus, 2 plus, 3 plus, the charge is greater will be the covalent character. Based upon these two rules, the Friedmans rule, now you go through the tabulation, that is the ionic and the covalent character. Now, the first one, ionic, low positive charge, NaCl, Na plus Cl minus, and high positive charge, Al3 plus. For example, sodium chloride, low positive charge. Low positive charge means it has a large cation and it is relatively small anion, making the charges to separate completely. So, they produce the charges, so it is an ionic. Ionic means it has the conditions low positive charge, large cation and small anion. Then, in aluminum triiodide, Al(I3), higher is the positive charge, 3 plus. So, the charge is 3 plus. So, it is a positive charge is higher. Larger the anion, there is no change or no complete charge separation. So it is covalent. When it is form a charge plus and minus ion, it is ionic. No charge formation here, it is a covalent. High positive charge Al3 plus, small cation, and it is a form a large anion. Now, come to the following picture. It explains the relative charge separation of ionic compounds. Here, low charge Na plus. The charge is increases, low positive charge, but the the cation is increases, Al Na plus, Mg2 plus, Al3 plus. Here, anion is the small one. So it forms the ion. So it is a ionic. They forms ionic. So the ionic character. Here, large cation Al3 plus, Al3 plus, Al3 plus. It is a large, higher the cation. Here the higher the anion, but here no changes in the ions. So it forms a covalent. Here it produces a compound Na plus, Cl minus. It produces ion, so it forms a covalent. It forms an ionic, and here it forms a covalent one. So these are about based upon the Friedmans rule. You have to sum of the ionic compounds. It shows the covalent character. Now come to the assignment. What is covalent bond? What are the types of covalent bond? The second one, explain the formation of methane molecule CH4. The third one, explain the formation of oxygen molecule O2. Then fourth one, what are the characteristics of covalent compounds? These 4 questions you have to learn and write one time. Okay students, thank you.